Have you ever heard about the SLAM term in survey industry? If you have, surely you have known it is one of the most popular techniques used in the developed countries such as United Kingdom, China and Australia. But if you're not, then I hope this presentation video could give you some insight about what is SLAM actually. Assalamualaikum and hi, my name is Muhammad HAKIMI bin Muhammad, a university student from UiTM Perlis branch. Under the supervision of my supervisor SR Zaki bin Ahmad Dahlan and my co-supervisor SR Dr. Khairi Afendi bin Hashim, I'm going to present the topic of my research, which is accuracy assessment of simultaneous localization and mapping data, or SLAM in the short term, in topographic survey. So, let me give you a quick rundown about what is SLAM actually. It is actually a method used by several instruments to capture fast real-time 3D data. It is commonly applied in handheld or mobile laser scanner with multiple sensors. So, what makes it stand out from the other method is it able to integrate multiple sensors such as LiDAR, camera, GNSS and IMU in one instrument. So, it is heavily dependent on this method how it generate the 3D data of its surrounding. Now, let us look at the several issues that prompt me to do this research. For the main issue of this research is other survey methods consume more time in complex and diverse areas, such is why I propose the usage of SLAM-based instrument, but it comes in own limitation itself. Firstly, unverified accuracy of its final output in diverse area. Next, unknown suitable SLAM data collection method for survey. This is due to no official regulation or verified stat from any type of references regarding on how to use SLAM-based instrument for survey purposes. Let's move on to aim and objective of this research. From those issues, I can create the aim of this research, which is to assess the quality of 3D topographic model using SLAM method for topographic survey. In order to achieve this aim, there are several objectives I needed to complete. Firstly, I need to identify the data collection method for survey using SLAM concept. Next, I need to generate 3D topographic model from the identified method. And last one, I need to analyze the accuracy of 3D topographic model with ground truth data. Based on those objectives, I propose several steps in order to achieve the aim. Now, for the methodology or step proposed to achieve the objective of this research, firstly, data collection in survey area. So, for the data collection method, I use the loop closure method with different number of GCP or ground control point distribution. This is because I want to observe if different number of GCP distribution could affect the accuracy of the final output, which is 3D topographic model. Next, the second step is point cloud pre-processing. So, in this step, we mainly use the GVI or Green Valley International software to do the georeferencing process and quality checking of the GCP using verification point collected on the study area also. For the third step, generating 3D point cloud. This step is based on the pre-processing output, and
From the third step also, which is the point cloud itself, we can generate the DEM or digital elevation model, but due to the software limitation of Leica Cyclone 3DR and the GVI software, we can directly produce the digital surface model, which is the DSM, and digital terrain model, which is the DTM. This is because DEM cannot be produced, and from those model we will validate it using ground truth data, which is in the fifth step, which is ground truth data validation. So in this step, we verify the 3D model of the using SLAM data based on ground truth data. So the ground truth data are collected using the GNSS method or conventional method, but in this research I probably use the GNSS method for fast data collection and reducing the time I need to complete this research. So after the ground truth data validation or the analysis process, I can achieve the good 3D topographic model that is suitable within the topographic survey standard. Now let us look at the result of those steps that I've conducted for this research, and we can see and observe how well does the SLAM can use to produce a good result for this method. Based on the methodology, I managed to achieve the result for Objective 1 and Objective 2. For the Objective 1, which is to identify the data collection method for survey using SLAM concept, I use different number of GCP distribution as I mentioned in the methodology before. So those number of distribution is first 4 GCP distribution, 8 GCP distribution, and 12 GCP distribution. In order to assess the horizontal and vertical accuracy of these three methods, I use RMSE calculation or formula. So based on the result of the RMSE, I managed to find that the GCP method is the most probable method to be used in this research. Although the 4 GCP and 8 GCP is eligible to use according to the topographic survey standard, but since the 12 GCP possess the lowest RMSE value of those three methods, it is chosen as the GCP probable method to be used for this research. For the result of Objective 2, which is generating the 3D topographic model from the identify method, which is in this case the 12 GCP method. So I managed to achieve the 3D topographic model using the Leica Cyclone 3DR software, which generate the DSM, DTM, and also the DTM model with height. So based on these three model, I can use to assess and analyze for the third objective, which will be discussed more in the discussion part. For the discussion part, it will mainly focus on the analysis of 3D SLAM model using the ground truth data validation method. So, how do I conduct this analysis? Is by I pick out 4 random points on both model. So, these random points are selected by according to the certain area in the model, such as steep hill area and open space area. So we can identify how the interpolation of the model affect on those certain areas. So the ground truth data will be the reference data for the SLAM model. So firstly, I do the error comparison, which is to observe the X, Y, and Z value for the SLAM model. So based on the error comparison result, we can see that the Z value or elevation value produce the highest error compared to the X and Y value. This is because, as claimed by developer, the vertical accuracy of the instrument is 5 centimeter. So it is quite high, since the regulation for the GNSS method also told that the vertical accuracy that is according to the standard of Japan is 6 centimeter. So it is quite a good accuracy, since it is nearly the same as the Japan circular. And the using the RMSE calculation, I also concluded from the error comparison for the 3D slime model. So for the horizontal accuracy of the 3D slime model, which is 1 centimeter, and for the vertical accuracy of the 3D slime model is 3 centimeter. This is according to ASPRS, or accuracy standard for geospatial data. It is within the first class. So based on this analysis, the 3D SLAM the 3D SLAM model can be used for the topographic mapping survey standard based on this research. But further study is really inquired to understand if the SLAM 3D model accuracy for the other method can be implied the same or not. Since the result have been achieved, I will now explain the significance and benefit of this study for the Malaysian survey industry. Firstly, SLAM method enable a faster and more efficient mapping survey method compared to the conventional and old method. Next, SLAM-based instrument require fewer procedure and can be done by one person. And next, SLAM-based instrument also is highly mobile and can cover areas quickly compared to the terrestrial laser scanner or TLS. And lastly, the study also validate the SLAM data to complement UAV LiDAR and TLS data itself due to the certain loophole that the instrument cannot cover. Now, we can see there are much more potential to the SLAM itself, such as it can be used for the topographic mapping, construction survey, mining survey, forestry survey, road survey, and BIM. So, in the future, I think the SLAM itself can be investigated further, and more research regarding the potential of SLAM in the survey industry can be advanced more with the newer technology nowadays.
Before I end my presentation video, I'm going to conclude several things based on this research. The first one is the horizontal and vertical accuracy of 3D model based on SLAM data can be verified to use according to accuracy standard for geospatial data or ASPRS standard. The second one is the model is eligible to use for topographic survey based on this research standard. And the last one is implementation of SLAM can be considered for future use in Malaysia's survey industry. I think that's all for me. Thank you for listening, and Assalamualaikum warahmatullahi wabarakatuh.